So basically, chemical kinetics is a part or branch of physical chemistry in which we study the rate of reaction and the mechanism by which the rate of reaction, and the mechanism by which the reaction proceed. So we can write a definition for this chapter. You can write the branch of physical chemistry which deals with the rate of chemical reaction. And the mechanism by which reaction proceeds. And the mechanism by which reaction proceeds that we study under chemical kinetics. So basically, we in this chapter are going to know about the rate of reaction and the mechanism by which the reaction proceeds. Okay. So just wait a minute. Please do write it. Let me know when you are done with this. Now, here the reaction are divided into three parts. The reaction is divided into three parts. Fast reaction, slow reaction, and then moderate reaction. And then moderate reaction. So if you are going to see fast reaction, so basically reaction takes place, or we can write reaction which takes place around just wait a minute, not takes place. Reaction which takes about 10 raised to the power minus 16 to 10 raised to the power minus 12 seconds. That reaction is known as fast reaction. Like we can take example for ionic reaction, or you can say it precipitation reaction. Like if you are going to react this AgNO3 into NaCl, precipitate will form AgCl plus NaNO3. So this will be your aqueous and this will be your solid. And both are in aqueous and aqueous solution. So generally the reaction which takes very less time, the fast reaction like burning of petrol, that is your fast reaction. But when we are going to talk about slow reaction, we can take example of rusting of iron, which take years to rust. Rusting of iron is an example of slow reaction, or we can write which takes more time, like it can take 1 day or 1 year or 10 years. That is called basically rusting of iron. That is basically comes under slow reaction. Is that clear?
Yes.
Now, moderate reaction, which takes basically reaction. Reaction stands for reaction. Reaction which takes place with measurable time, minute, hours, like this, measurable time, measurable time, like 1 hour, 2 hour, you will get the product. So there is a question. What do you think if you want to if you want to study the rate of reaction out of this fast, slow, and moderate, for which type of reaction you are going to choose to study the rate of reaction, fast, slow, or moderate? Austin and Humam.
Moderate.
Moderate. Why? Because you know that this reaction, basically fast reaction, is very fast. Very fast. You can see 0.0000 this second. That's why you will not be able to do this. You will not be able to read the rate of reaction, study the rate of reaction. Slow is very slow. If you are going to study, it will take years to take out a result. So what we choose to study the rate of reaction, that is your moderate rate of reaction. You can take example as well here, as I didn't give any example here. So we can take H2O2. If you are going to break this with the help of electricity or what energy, this will be converted into this. This is an example of moderate reaction. H2 plus I2, that will give you 2HI. These are some example of moderate reaction. I'm going to write some more, like if you are going to take this sucrose and then if you are going to put this in water, you will be getting C6H12O6, which is glucose, plus C6H12O6, which is fructose. Are you getting my point?
Yes, sir.
Please do that. Let me know when you are done with this.
Done so.
Very good. Now see, we are going to study, since this chapter is going to only deal with, which deals with the rate of chemical reaction and the mechanism by which reaction proceeds. Now, what is rate of reaction? So write this topic, rate of reaction. RXN here stand for rate of reaction. Now, so first of all, I'm going to, basically this is time taken to react the time taken by the reaction per unit time, or change in concentration of reactant or product per unit time, that is called rate of reaction. So we can write it is defined as the change in concentration of reactant or product with per unit time, or unit time you can directly write. So it's very, very simple. As you know that this is a rate of reaction. When a reaction is start, there will be something that is reactant. Initially, the product is zero, but by the time when reaction proceed, reactant decreases and product increases. So change in reactant and time taken to change, time taken to that change, and or you can write a rate is equal to change in product upon time taken to change. So we can also write here, i.e., that is decrease in concentration of reactants or we can write decrease in concentration of product, decrease in concentration of reactant and decrease in concentration of product. So we can write a formula or mathematical equation from this. Rate of reaction is equal to, or rate is equal to, change in concentration of reactant or product divided by time taken, divided by time taken. This is what a rate of reaction is called. Okay, so please do write up to this. Oh. Let me know when you are done with this. Very good. Humam,
Yes, sir.
okay. Now see, let's say a reactant is converting into product. At time t equals to t1, reactant is R1 and product is P1. Basically, I'm going to show you from here on this. At time t equals to 0, the concentration of reactant is R and concentration of product is 0. As reaction is about to start. At t equals to t1, the concentration of reactant becomes R1 and this becomes P1, product P1. And if you are going for at time t equals to t2, it becomes R2 and this becomes P2. Is that clear?
Yes.
Yes, sir.
Now, if you want to write the rate of reaction, that I'm going to write ROR, rate of reaction, that will be equal to negative sign R2 minus R1, concentration of R2 minus R1 divided by T2 minus T1. This is rate of reaction between these two. If you are going to write between these two, you are going to write R1 minus R upon T1 minus 0, that is T. Are you getting my point, both of you?
Yes.
Or if you want to write in terms of product, you are going to put positive sign. I will tell you why positive, why negative. P2 minus P1 divided by T2 minus T1. As you know, the reactant with the time decreases. Are you getting my point? Yes or no? Reactant with
Yes.
time decreases, that's why negative sign, and product with time increases, that's why positive sign. Please do write it. Let me know when you are done with this.
Done, sir.
Okay. Now, if you are going to plot a graph, it's very easy to plot a graph for this. Now, see, this is concentration versus time graph. Concentration versus time graph. If I'm going to plot this graph with red, this is like this, and with green, light green, it's like this. Can anyone tell me the which one of these are for reactant and which one of this is for product?
Red is reactant.
Red is your reactant and this green is your product. Because you know that product started from 0. Initially, the product will be 0 and you will have some reactant. With the time, reactant decreases and with time, product increases. Is that clear, Humam?
Yes, sir.
Now, have you heard of this velocity? You have heard of this velocity, right?
Yes.
So with respect to time, velocity can be of two types: average velocity and instantaneous velocity. So I know, I think that instantaneous, both of you knows what is average and what is instantaneous. Average velocity, that means over the time period, like between 10 minutes to 20 minutes, 10 minutes to 15 minutes, 0 to 10 minutes, what is the average velocity. And instantaneous velocity is something that is at that instant, like at 10 minutes or at 10 seconds, what is the velocity? That is your velocity, instantaneous velocity, right? So here the rate is also divided in the same way. Rate can be divided as average rate, that means over the time period, and instantaneous rate at a certain time. What is the rate? Are you getting my point, both of you?
Yes.
Okay,
Yes.
so please draw this graph, then I'm going to show you average rate for reactant as well as time. Let me know when you are done with this.
Yeah, done.
Okay. Now, if you are going for average rate, so what is average rate? So we can write rate of a reaction measured with interval of time. Interval of time. That rate is equal to average rate. So if you want to calculate average rate, that will be equal to, directly I'm going to write negative delta R, change in reactant upon time taken, or I can write plus delta P, change in product over a time period, interval of time, upon delta T. Basically, rate of reaction will always be equal to each other. That means rate of reaction of a reactant will be equal to rate of reaction of product. Are you getting my point? The change in concentration of reactant per unit time will be equal to change in concentration of product per unit time. Is that clear?
Yes.
You know that when reactant is converting into product, whatever change or whatever you can see, whatever reactant is converting into product, the time is also same and the change in concentration is also same. That's why. Okay. Now, if I'm going to plot a graph again for this reactant, let's say this is the scenario. This is the scenario. This graph is between concentration versus time. And here it is concentration of reactant and this is concentration of product. So with this, it is T2 and with this, it is T1. So you know what to do. If you want to calculate rate of reaction, what it will be? R2 final concentration minus initial concentration divided by T2 minus T1 over an interval of time. And since it is reactant, you are going to put negative sign because it decreases and gives you value in negative, and due to this negative present outside, that makes it positive, because concentration in negative, that doesn't mean anything. Like will I say it is number, like mole is number. So can I say like today in my class -2 student is present, negative number will not be negative, right? Are you getting my point?
Yes.
Please do write it. Let me know when you are done with this.
Done, sir.
Okay, very good. Now I'm going to give you a question, and that is, just wait a minute. It's just like here it is given time in second and concentration of reactant in mole per liter. At time t0, this has a concentration 160. At time 10 second, this has a concentration that becomes 80. At time 20 seconds, the concentration becomes 40, and at times 40 seconds, the concentration becomes 2.5. Now the question is find average rate. Sorry, question already written here. Average rate. Find average rate for all this time period. Find average rate between 0 to 10 seconds, then 20 to 30, 10 to 20 seconds, then 20 to 40 seconds. So write the calculate the average rate. Are you able to solve this? Both of you, Austin, Humam.
No, sir.
Oh, it's very easy. What I told you. See, average rate. What we are going to do the first 0 to 10. Average rate will be equal to minus delta R, since we are talking about concentration of R upon delta T. This will be equal to. You can see minus will be there. What is delta R? Change in reactant. So this is the final reactant between 0 to 10 second, and this is the initial. So 80 minus 160 divided by time taken, you can see the time is 10 minus the initial time is 0. So it will be like this. If you are going to subtract it, it will be minus 80 and there is negative outside upon 10, which makes it 80 by 10. This will be equal to 8. Now you can see in numerator, what is the unit? Mole per liter. Mole per liter. Yes or no? Mole per liter in numerator. And in denominator, what is your unit? Second. So it will be 8 mole per liter per second. Are you getting my point?
Yes.
Can you do the rest, Humam, between 10 to 20? This will be your T2, this will be your T1.
Yes, I can.
This one will be your R2, this one will be your R1. Any answer for the next one? Very good. So, Humam, if you are going to calculate the average rate for next one, it will be 40 minus 60, 80, 40 minus 80 divided by 20 minus 10. So what it will be? 40 positive divided by 10. So it will be 4 mole per liter per second. Is that clear, everyone? Now the
Yes,
next one you can see will be between what time? Where it is 40 and 20. So it is 2.5 minus 40 divided by what is the time? 40 minus 20. So it will come out to be something 1.875 mole per liter per second. Right, Austin?
Yes.
So, Humam, you can see by the time passes, the rate is decreasing. So we can write a point here. Note, as the time increases, the rate of reaction decreases. You can easily see this initially at mole per liter per second, 4 mole per liter per second, then 1.875 mole per liter per second. Is that clear to both of you?
Yes.
Please do write it.
Done, sir.
Very good. Now we did it for reactant. We can do for the product as well. The average rate you can see. It will be like this is your graph. I'm going to plot. This is your concentration. The previous one was for reactant, and now this is for product. So you know product will start from 0. Now you can do this as well. This is your at time t1. You have the product concentration of product as p1. And at time t2, concentration of product is p2, and this is your t2. Is that clear? So this is if you are going to calculate average rate will be equal to p2 minus p1 divided by t2 minus t1. You can write this. Let me know when you are done with this.
Yeah, done, sir.
No. Now we are going to discuss about instantaneous rate. What is instantaneous rate? So at any instant, so we can write the rate of reaction measured with infinitesimally small interval of time. Interval of time. That is your instantaneous rate. So we can also write instantaneous rate. That means basically delta t change in time tends to 0. This can be equal to delta we use for big change and d we use for a small change. So we can write minus d of r upon dt, which will be equal to plus d of p upon dt. The rate of reaction will be always equal. So another point that we can write, measured, this can be measured experimentally. This can be measured experimentally by taking slope of tangent. Let me know when you are done with this.
Done, sir.
Very good. Now we are going to draw the graph for this as well. So this is your graph. I'm going to tell you. This is for reactant. You can easily understand. This is your concentration versus time. Now, if you want to draw, if you want to calculate the rate, you have to draw a tangent. Are you getting my point, both of you?
Yes.
You have to draw a tangent. This is your tangent, you can see. And with this time, this is your, I'm going to take a triangle in this. That is like, this is your dt, we can say dt and dr, a small changes. So instantaneous rate can be written as minus of slope. As you can see, the slope is more than 90 degrees. So it will be negative of slope. Negative is there, slope is there. So due to multiplication negative into negative minus d of r upon dt, we can write the instantaneous rate becomes positive. So please do write it. Negative is only showing the decrement. Okay. Let me know when you are done with this. I'm also going to draw the graph for product as well, which is very easy. So for this, the product will go like this. And now if you are going to draw the something like this, then what do you need to do? This is your, let's say, the tangent. And then you can make a triangle like this. And this is your change in concentration of product. This is your TT. This is your concentration. This is your time. So if you are going to calculate instantaneous rate, it will be dp upon dt. Very easy. Let me know when you are done with this.
Done, sir.
Very good. Now see, if I'm going to take a general equation, let's say there is a reaction AA plus BB will give you CC plus DD. You know that a reactant is finishing with time, right? So for reactant, we use disappearing because with time it has started disappear. And for product, we use appearing. So we can also write rate of disappearing. This disappearing will be for reactant. Disappearing of A. Rate of disappearing of A. Since it is reactant, we are going to use minus D of A, or either you can use delta A upon delta T. Are you getting my point? Negative will be there since it is disappearing. So another we can write, since we have two reactant, rate of disappearing of B will be equal to minus D of B upon dt. You can write delta B upon delta T. Now we are going for product. So rate of either for product we use appearing or either we use formation. So rate of appearing or formation, since we have two products, so we are going to mention this rate of appearing or C or formation of C plus D of C upon dt, or you can use delta A delta C upon delta T. Again, we have two products, so rate of either we can write appearing or formation of D, that will be equal to plus delta D dd upon dt. Are you getting my point? You can use delta as well, delta C upon delta T. You can use delta D upon delta T. You can use this as well, delta B upon delta T. But don't forget to put negative sign in front of the reactant. The rate of appearance and disappearance will not be appearing, not appearance, it is good. Rate of appearance will be good. Rate of disappearance. Let me know when you are done with this.
Done, sir.
Okay. I'm going to give you a question. Write the rate of appearance or disappearance for the following reaction. For you are going to write the rate of appearance or disappearance only for this 2SO2 plus O2, that will give you 2SO3. You can write this. Are you done with this? Are you done with this? See, this is two reactant you have. So we are going to use a rate of appearance, sorry, disappearance. A reactant it is. So a rate of disappearance will be equal to minus d of SO2 upon dt. Again, rate of disappearance of this is your SO2 and this is your of O2. This will be minus d of O2 upon dt. Now there is one reactant rate of appearance of SO3 that will be equal to plus d of SO3 upon dt. Is that clear? So whenever you are going to write the rate of appearance and disappearance, this stoichiometric coefficient will not be involved. And this rate of appearance and disappearance can be different for reactant, different reactant and product. Are you getting my point, Austin and Humam?
Yes.
Yes.
Now, are you done with this? Can I change the slide? Both of you, can I change the slide?
Yes.
Okay. Now see, consider a reaction. Consider a reaction like this. Consider a reaction 2A plus B that gives you 3C. Now, if you want to write either it can be rate or either there will be question for rate of reaction. When we are going to talk about rate of reaction, then stoichiometric coefficient will also be involved. And when we are going to talk about rate of reaction, the rate of reaction of each reactant will be equal to each other as well as to the product. Are you getting my point? So how I'm going to write? Whatever is the coefficient that will come into denominator. And since it is reactant, so I'm going to write negative. And then d of concentration of A upon dt, which will be equal to what is the coefficient of this one? Negative, because it is a reactant, and one that is you can either write or not, it won't affect, d of concentration of B upon dt. That will be equal to positive since we came to product. Whatever is the coefficient, you can see 3, it come into the denominator, d of C upon dt. Is that clear, everyone? Yes or no?
Yes.
So this is how you write rate of reaction in terms of coefficient. If rate of reaction, if you want to write for a reaction, you are going to do this. Rate of disappearance, appearance, you are not going to involve this. Please do write it. And write the rate of reaction for this. If you have given A M plus B Q, that is giving you CT plus DS. This your A, B, C, D is your coefficient. Write the rate of reaction. Are you done with this?
Yes.
So rate of reaction, what how you have written is minus 1 by a d of m upon dt, right? That will be equal to minus 1 by b d of q upon dt. That will be equal to plus 1 by c d of t upon dt. That will be equal to plus 1 by d of s upon dt. Is that clear? So
Yes.
this is how we do this. After this topic in the next chapter and next class, we are going to talk about rate expression law. Please do practice on these topics. Very important. Okay. Is there any doubt